Well, good afternoon, everyone. I hope you and everyone you care about is keeping well and doing great. Thank you for coming to the talk. My name is Ishan, and I'm here to talk about how you can perform due diligence as Android engineers. Now, there's a lot of jargon in this title, but I'll try to dumb it down next. What is the talk about? In a nutshell, this talk is about the things to consider when you're integrating new libraries into your Android project. Why am I giving this talk? I've been working in similar projects for the last 2 years, call it luck or not, but I've been integrating third-party SDKs. Does not really sound fun. However, I've learned a lot of things, and one of the key things that I learned is that different companies have different ways or proposals to bring in new libraries into your project, and they all try to ask you questions beforehand so that we don't need to worry about those things after we've actually started integrating or even shipped the app. So through these learnings, I've come up with a framework which I want to use for myself in future and hopefully share it with you so that you can save time, money for your company, and also frustration for developers, which might come from certain aspects that you fail to evaluate early on. So the agenda, let's look at that. We'll first briefly discuss what due diligence means. Then you'll find out why you should care about it, followed by how can you perform it as an Android engineer or a mobile engineer in that regard without driving yourself crazy. And then I'll describe the broad categories for consideration that I've kind of bundled things into, so you can even do it asynchronously in a group or within your team by splitting responsibilities. After that, we'll actually go ahead and deep dive into each category and then see what we're going to evaluate in those categories. Finally, I also want to leave you all with 2 questions that you should ask yourselves, maybe your teammates, when you're bringing in new libraries. And then if there is time, I hope there is, we can also do some questions and answers, to which I'll always answer, I don't know. So what is due diligence actually? I'm going to read out the definition that you'd find on the internet, but I've slightly tailored it for ourselves, moving away from the lawyers. Due diligence with respect to third-party SDKs is the investigation or exercise of care that a reasonable business or a developer is normally expected to take before entering into an agreement or contract with another party with a certain standard of care. Now that's how a lawyer would describe it. I describe it as an insurance policy for third-party integration I'm about to make, so that if something goes wrong, I know I'm covered. Why should you care about it at all? So if you love your business or your customers and your fellow developers, you'd want to be as cautious as you can when integrating new libraries. This is not always possible, especially when you're in a fast-paced environment, a startup trying to chase a deadline or try to ship Android 1.0, as we heard from Chet yesterday. However, it is highly recommended so that you don't harm the quality of your app, your developer satisfaction, or most importantly, the business metrics themselves. Now think of it like a visit to the dentist. No one really likes it, but we all know how important it is for our oral health, and that's why you have to do due diligence. And I hope now I've convinced you that we have to do due diligence. Let's look at how do we do it exactly. So in my personal experience, each team and person has their own way of analyzing things. In this talk, I've tried to include most of the things that I believe could go wrong when bringing a new library into your project. However, I would like to give a disclaimer that in no way is this an exhaustive list. So if you analyze something based on this and something goes wrong, please don't hold me to it. So overview of categories, the framework I've come up with broadly covers 5 different categories on which we need to evaluate every new library or an SDK. This broad classification like I mentioned before, also helps probably in splitting the work among various teammates, because you're going to see the list of the things that need evaluation are pretty long, and it might help that multiple people look at it. Also, more eyes that you get on something, the better it is for you to get feedback on. The first one is the documentation itself. The second is the integration part of your SDK. The third is the customization. Fourth being security. And fifth being performance of the SDK and other things related to the application that you're working on. Let's talk about the documentation part of it. The first and the foremost thing that you do whenever you're tasked or you're trying to find out if you want to integrate something is you go ahead and you try to find the documentation related to it, right? So this can be further divided into 5 subtopics. The first one being the licensing structure. Second one being installation and usage of the library. Any pitfalls that are relevant for this library that you should know beforehand. What's the level of detail, and how frequently is the documentation updated? So this is mostly relevant for open source libraries, and for an open source library, an open source license essentially allows you to freely use, modify, and distribute your software without any strings being attached. Now, if you've ever read a GitHub repository, at the very bottom of every readme.md file, you'd see something that says an MIT license or an Apache license. And there are various licenses that people can choose from. So MIT license essentially says, do whatever you want with this, just don't sue me, right? The Apache license says something similar, like, do whatever you want with this, just don't sue me, but it just says it with many more words. Probably a lawyer wrote it. Now, while this may not happen very often when you're integrating with third-party vendors, because they already have a proprietary license, so you'd be signing a deal outside the scope of the project itself, certain open source projects don't really like a lot of licenses. An example that I can quote is, if you have an Apache license and you're trying to put your project under the Apache Software Foundation, they will not allow you to bring in any dependency that does not have an Apache license. So you cannot bring an MIT license dependency into an Apache project. Now that's a rule that they have. I don't know why, but something to consider if you are building a project that you're going to open source in future, or you're trying to integrate with your project. In the installation and usage aspect of the documentation, you will try to assess how you're going to install and use the library in your project. Is it always called on demand, for example, like an image loader when you're actually using it? Or do you need to initialize it at an app start, for example, a tracker or a crash manager, logger, something like that? And does it require an application context or an activity context, those kind of things? These are the important things to consider, because what if the SDK that you're trying to integrate with holds onto your context, leaks it, or does some weird things, especially it's your app and that SDK just plays a small part in that. The next is the pitfalls. Here you'll be scanning for special notes or gotchas in the documentation. For example, if a library needs access to the camera permission and will not work without it, then you might have to have a hard dependency on that permission. And if your app already does not expose that permission, then you have to go back to product or design asking, how do we design this flow so that we can still ask for this permission without actually hurting the user experience. And I'd like to especially mention, if you don't find these things in the documentation phase when you're reading it, and you actually discover these pitfalls while you're implementing or integrating with the library, this kind of is a red flag, and you're kind of getting yourself into trouble. So if you can, try to avoid that by either talking to the vendor itself, your contact point, or the owner or the maintainer of the library. This is the best time to do that. The next thing is level of detail. And here you should look at how is the documentation structured. Does it have various scenarios of usage? Do they have a blog post, an article, or do they have videos recorded? And this actually directly impacts you in terms of velocity, because if the documentation is poor, and let's say you're using an SDK from a vendor that is in another country, in another time zone, maybe their consultant who's actually going to answer your emails or through whatever channel may not be available for a long period of time, and this is actually going to be a blocker for you or your team. While integration, this may not be a problem, but imagine if you're firefighting something and it happens to be from this library, you actually need access to a good level of documentation to be able to answer questions that you or your team might have. The next part will be the frequency of updates, and this will be the last one in the documentation phase. And this is also a crucial thing to assess. While the SDK or the library might be updated frequently, might be patched frequently, or might be getting new features very frequently, but an important question to ask yourself is how often do the owners actually update the documentation itself? Because imagine a documentation which has a bunch of video tutorials teaching you how to use this on an Android Studio, and that is actually from 2019. However, as we all know, it's not very easy to keep up with all the changes in videos. They might actually not update those and still tell you to follow what latest things exist. And then you're kind of struggling to find out how do I actually do this today, because the tutorial says how it was supposed to be done in 2019. And also what you need to consider is if the documentation supports telling you about breaking changes in advance, and how soon are they communicated? Do they give you, or have they given in the past, any grace period for you to migrate? Also, when you migrate to a newer version, what happens to the apps that are not yet using the latest SDKs? How do they follow the deprecation policy? The next part that we're going to discuss about is the integration phase. So far, we've only been doing a lot of reading and not writing any code yet. And this should allow you to actually gauge what kind of project or trouble you're getting yourself into, and if it's going to be an easy process or a painful process. And at this point of time, if you find it's painful, it's better to pass it on to another developer, citing this is a great library and you should definitely integrate it. And then now, because we're going to start diving into the code, I'm going to talk about how are we going to actually consume and deliver the library into our project. What dependencies is it going to have? Are there going to be any minimum SDK requirements for your own project? What's the permission look like? And how are you going to initialize the library? What sort of error handling and logging does the library provide? And anything that has to do with ProGuard, if at all. So the consumption and delivery basically refers to the mechanism of pulling the dependency into your project. Now, it could either be a jar or an AAR file that they're distributing that you might have to download, and then they'll ask you to put it in your /lib folder. Or it could be distributed via Maven or JCenter or any such public distribution repository. An important consideration here is, do you have access to the historical versions of the SDK, or do they only allow you to download the one latest version of that SDK? In case you ever wanted to roll back to a particular version. Also, a recommendation here would be, if you use, or if your company uses an internal artifactory, try to mirror that either to the public repository, or when you get the artifacts in the AAR or the jar format or the zip format, just upload them and consume it via that place. That way you will not be checking in the library into your Git source code. And also, you can always maintain a history of the versions that you are ever going to update your app with. The next part is the dependencies, and the dependencies here specifically refer to what are the dependencies that this third-party library uses. An example that comes to my mind would be, imagine if you're going to use retrofit and it depends on OKHTTP, and if there was a version that retrofit would specifically depend on, then this is an important consideration for you. I'm trying really hard not to take names of any other vendors without causing trouble to myself. And the impact that this might have on your project will be that there are times when you have to update certain libraries to use another thing, and this could actually break things in other parts of your app, which I've seen happen in a bunch of cases, not with third-party libraries, but other things in general. Coroutines are a good example. Jetpack Compose is a good example. It becomes a real pain for a lot of the platform engineers or the build engineers who have to scramble to make things work just to get that library version bumped up for you. So a point that I wanted to mention at the end was make sure the surface area of the dependencies that you're going to bring in is minimal. It's not easy to avoid that thing, but something to keep in mind. If you have an option to use an alternative of that library, you can try to do that. The next one is pretty straightforward, as you can read from the name. What is the min SDK requirement? Certain libraries might just ask you to bump the min SDK version, especially if you've been supporting a lot of old versions. This is not a deal breaker and does not usually happen with a lot of libraries, and you can, but it is important that you don't rule this out at all. Next is certain libraries would require access to hardware or any such permissions. For example, if you're building an app that has to do something with images, or you're introducing images or videos, you now want to have the ability to capture video so that they can capture that through the camera, and that's the hardware that you might want to use. Or if you're doing something with respect to location that you don't really have in the app right now, then the app needs the location permission. And if your app does not already have those permissions, then the thing is that you will have to ask it at runtime, which means, again, you're going to have to involve design and product. So you have to ask yourself, is there a way to use this library without introducing those hard permissions if you're not going to use those features? And if the answer is yes, then it's a go ahead already. If not, are there alternatives, or are everyone on the same page about bringing in those big changes to your project? Next is, the initialization, and as I already mentioned in the documentation phase, this does not have a lot of things to do. You usually be using 1 or 2 lines to initialize your library, but now is the time to put it in practice and see if the initialization actually happens the way it is described in the documentation. The next part is the error handling and logging, and here you have to probably assess how are the errors and warnings logged, what is the granularity of error that the library exposes, how much information can you get from when something goes wrong in the library, so that you can infer the problem and try to fix it yourself rather than having to go back to either the documentation or need a human support to fix that problem. And also you have to make sure that these errors are not actually logged in production, which is said, but I will still note it here. Then some SDKs even might want you to add the ProGuard config, so you either have to do the ProGuard config file or the consumer ProGuard config file. And what we all know, since we don't mess with ProGuard changes on a day-to-day basis, at least not majority of people do, it is a good thing to flag it to someone who manages the releases or build pipelines that, hey, we're going to change the ProGuard files. Let's just make sure that nothing else breaks because of this. The next part that we have to look at is the customization. And now that you've actually integrated the SDK either in your app or in a side project that maybe you're building a POC with, it's time to see what level of customization does the SDK that you're trying to work with offer you. And when I say customization, it is mostly in terms of the user interface. So think of it as if this SDK offers UI components or flows that you're trying to use, can you customize them? And we'll see why it's actually relevant for a lot of big projects or even smaller companies or startups. Eventually, it's going to become important. So the 5 topics in this section are localization, accessibility, user interface configurability, user experience configurability, and also the dark mode compatibility. So this essentially relates to the ability to be able to localize your apps. So if your app is available in multiple languages and it supports right to left languages, then you want the SDK to also have that support. Otherwise, it's going to look really weird, especially if it exposes a user interface. An example that I could give you is if your app is trying to do some sort of photo or ID verification, and you're kind of using a third-party vendor for that, you'd want to make sure that for people in different countries that can read everything else in your app in another language or their native language can also go through those flows in that language itself. And if they don't allow you, or if they don't provide translations to you automatically, you can try to find out if there is a way to override the strings, especially if you were to just get a hold of all the string.xml files in that SDK, you can just actually override everything by using the same keys and then provide translations by yourself. The next part is the accessibility, and this relates to how your apps are accessible. And again, if you have a big enough user base, you want to cater to be inclusive to a lot of other users, and also want to rank higher on the Google Play listings and stuff. Accessibility then kind of becomes important part, and you have to assess the SDK if it is taking care of all the accessibility options. If they don't do it directly, then the question becomes, is there a way for you to somehow support it? The next part is the UI configurability, and this kind of refers to the individual component customization. For example, are you allowed to change the button colors, or the font size, or the button size itself, or maybe the font size itself? And for apps that have a lot of users, have a very significant presence, branding is an important thing, right? And you don't want to move away from your brand or whatever way you're displaying your user experience. So this level of customization kind of becomes an expectation for you to have. Very rarely would you see a very different user experience in these apps. And this is an important thing to assess early on, because your designers are going to be really mad if they can't really customize the things, because then they're just messing around with the flows. The next part is the UX configurability, and this relates to the fact if the SDK provides you with a flow to do a certain level of things. For example, again, if you're using an SDK to add filters to your app that you don't want to build yourself, or video editing feature, is it a multi-step process? Most of the time, yes. And are you allowed to change the flow as you need? For example, you may want to allow user to just add the filter and then upload it without doing any other shenanigans. Does the SDK allow you to terminate the process early? Another thing here is that, does the SDK give you hooks into all the steps of the process to find out if the user dropped out from that multi-step process, to be able to analyze how people are behaving and where is the bounce off happening, so that they can decide for if they really want to continue using this SDK or not. The next part is the dark mode compatibility, and this is the last part. It happened very recently when I was trying to do something, and we were trying to test out an SDK, and surprisingly, one of the developers had dark mode enabled on their device, and what we realized was everything worked fine when the dark mode was not enabled, but when the dark mode is enabled, the SDK just goes, I don't want to say it. So does the UI look really weird when you have the dark mode enabled? If the answer is yes, then you might want to talk to the developers. If your app actually supports dark mode, then this is also kind of a red flag if the SDK does not support it, and you should raise it. Try to get it in the app, or somehow allow your designers to probably pitch in and work together with the other team to get dark mode support there. The next part is security. So when you're done integrating, you've kind of figured out about the customization part. As soon as you start bringing this code in, you might also want to start involving security. And then they're going to ask you some generic questions like, What kind of data does this SDK collect? What kind of storage access does it have, or what does it do with the data? How does this SDK communicate the data that it collects with their own servers or wherever they're trying to send the data on the device? Is there some sort of data encryption that this SDK offers? Do they do any sort of tracking of users? And at the end, is there any PII collection, storage, or communication? PII, for those who don't know, means personally identifiable information. And this becomes very relevant if you're in California because of the CCPA laws, and if you're in Europe because of the GDPR regulations. So data collection basically would refer to any sort of data that the SDK is going to collect and then do something with it. It may not leave the device, but you still have to know what data it is collecting so that you can ensure that this data will be disposed of properly or will not be leaked eventually through any sort of lapse if it were to. And the data storage, again, relates to the same thing. When you capture something, when it's in memory, what happens if the app goes to the background? Do they store it on device? Do they just purge it? Or what do they do with it? And if they don't do any of that, do they actually communicate or transport that data out of the device? And this is all, again, that you would have to consider. Data encryption would have to be considered in two cases. One, when they're actually reading it and maybe storing it on the device, that you have to make sure it is still isolated from all the other apps that are existing on the device. And even if someone gets a hold of your device, no one can actually decrypt that data or like just plain read that data. And also, when they're communicating this data back, are they using the supported security protocols, HTTPS, or whatever sort of communication practices that your company product uses? Then it will be about the tracking. Are they doing any sorts of marketing or functional tracking? Some SDKs do it, some don't. Some offer it as a personalization experience. Pretty sure if you're now in Europe and you're doing any sort of tracking, you have to get the consent from the user. If you don't do that, be ready to pay about 4% of your company's revenue. So this tracking question becomes really important, and you have to know what kind of things are being tracked. If you cannot avoid the tracking, then you have to think about how do you get the consent and when do you get the consent from the user about this thing. The last step is the personally identifiable information, very tightly related to the tracking that we just talked about. Is there something that the SDK does to leave a footprint or a fingerprint on your device to maybe later on find out if this user had done or demonstrated certain sort of behavior? Is that PII handled perfectly? If yes, then you're good to go. If not, it's a good time to involve your legal team and also your security team to understand and also inform your users about it, what you're collecting, what you're storing, what you're transporting, and then how can your users get rid of it if they were to delete their accounts and not use your product anymore. And we have to move on to performance. And performance can then be further split into about 7 topics. The first one is build, and I didn't think about it until last night when I saw Iñaki. I really added it in the morning today. APK and build size. Then the third one is the startup time, memory and disk usage, network performance, battery performance, and also the user interface performance. Now, when it comes to build, most of the time third-party libraries will not impact your build, but there are cases certain third-party libraries will be like, hey, we offer an annotation processor to make your life easy, but to make your build engineer's life hard. So when you bring those kind of SDKs into your project, please be very careful to consider this before you do it. Ask for them if it is okay to do that, and also how easy will it be to get rid of it at a later on stage. The next thing would be the APK or the app bundle size. Again, if it's just pure Kotlin code, usually, or Java code, it's not going to affect you too much. But if you're doing some sort of like an ML model that you want to ship with it, or some sort of a native library that does a bunch of heavy lifting on your device, then you're kind of looking at bumping the APK or the app size. Certain times this will not be a problem because now Google allows you to split the things based on the device architectures, but still something to consider. As you all know, Google has talked about is at a number of Google I/Os and also conferences that app size directly impacts the way your app is downloaded and perceived and used, especially in the markets that are still emerging, where data is still costly or the devices don't have a lot of storage. This kind of becomes important for you. Then startup time is another thing that you might want to consider. A lot of SDKs, especially that want to hook into your app very early on and kind of compete with everything else to get access to the first ever entry point that they get into your app process. Analytics or trackers or crash management systems, they do this a lot. Or also deep link processors. They want you to hook themselves into the app as early on, and you have to make sure that they don't actually end up degrading the startup time or the app load performance, and it's a really important consideration for you to make. Then the next one would be memory and disk usage. Again, any memory heavy or disk heavy or data intensive SDKs, anything that has to do with video editing, image, or maybe geospatial data or something like that. This is a concern, and then you have to find out how does the caching happen. Does it compete with an existing cache in your app? Does it actually increase the size of the disk space that your app uses, forcing the users to maybe delete or uninstall the app when the time comes to make a decision when they're running low on device in your on the phone? Then this is also an important consideration, how easy it is for you to just purge the cache if needed. The next one is network. Here you have to check how does the SDK essentially does networking. This is mostly related to the security part of it. Are they just using plain text communication? Is everything going through HTTPS or not? How often are they making requests? How much data are they downloading? If you actually care about the data usage on your user's device, then this also becomes an important consideration for you. Are their network endpoints stable enough? Do they have very fast or like very small timeouts? This is again something that you will have to consider. And then comes the part of the battery. Again, most SDKs do not directly impact battery, but it's the features that you're trying to build with those SDKs that might have an impact on battery. It's also very hard to like pinpoint which SDK is doing that. You're probably going to do it through a feature and then try to find out if it actually is draining a lot of battery. But why I bring this up is because now a lot of operating systems, not just the pure vanilla Android, but like also the ones that Samsung and other phones have, they try to flag apps that have been draining battery or doing something in the background. So you're kind of going to get a bad user perception of your app. And again, if this SDK is notorious for doing that, if you can find out some sort of information without actually having to ship, this is something that you will have to inform your team about early on. And the last part is the performance of the user interface. Again, if this SDK offers any sort of UI, either components or the flows themselves, how janky are these, or do they perform smoothly? Do they add value to your app, or do they actually hurt the existing flows that you have? And if it is not smooth, what causes the jankiness? Is it something that you're doing wrong, or is it the SDK itself? Again, not going to happen very often, but something we should not forget about. And at the end, I want to leave you with two questions that I would like you all to ponder over whenever you're assessing these things. First is, can you leverage dynamic delivery? So if you're going to introduce SDKs into your apps, essentially they're for certain features, do all your users actually need those features? And is the SDK heavy or like big enough that is going to contribute to a significant amount to your app size? Then can you just dynamically deliver those features or bundle with the SDK on demand? Obviously, this comes with the caveat that you can only do this to to the devices that actually have Google Play and that infrastructure, this will not really work with, for example, the devices that exist in some countries that don't have Google access. So that's why this is not going to fit in everywhere, but it's something that you should think about and maybe give it a try. And can you prevent tight coupling with an SDK itself? Doesn't matter how small or big that SDK is, it is always to prevent yourself from tightly coupling with that SDK so that in future, if you want to try something else, the interface implementation can just be swapped with whatever dependency injection you're using, and then you can try out another SDK without having to say, oh, we'll have to make changes everywhere, and it's not going to be easy to try something out. So instead of locking yourself in, even though there is a contract, but you can still try to do it at the code level, you can try new things. If there's something better that exists, it should not be very hard to bring it in and remove the old SDK out. With this, I would like to end my talk, and I would like to tell you, if you want to know how we flip bits at Tinder, you can go to this blog. It's called medium.com/Tinder-engineering. If you're interested in working with any of us, we have a booth here. You can also go and visit life@tinder.com. And if you want to connect with me, that's my Twitter. If you want to shoot any questions towards me, always happy to answer. And if you have any questions, we have about 3 minutes, and I'm happy to take any questions. Thank you so much.